Okay, so one of the questions on your review, what number is this? 129. Quite a few questions to do, eh? Okay, 129, they've given you a triangle and they've named it, okay? They call it triangle CAB, CAB. They tell you that angle C is 30 degrees, and they tell you that angle A is 80 degrees, okay? So actually, the type of triangle I put up here is not a good one because this is not going to be a right angle triangle. Let's get rid of that. We'll actually draw this triangle using lines.
I have a question.
Yeah. Okay, so, and the last thing they tell us is side C is 27 centimeters in this question. Okay, so side C, 27 centimeters. Okay, so now what we're going to do is we need to create this triangle. One side, or one angle's 30, one angle's 80, and one angle is, do we know the other measurement?
No.
They haven't given it to us. Can we figure it out? Yeah, we can definitely figure it out. So this is triangle CAB, so we're going to just quickly name it. We'll call this C, A, and B.
Should I just be writing this down sometime?
That's okay. C, A, and B, because these notes I'll print for you, unless you got to put it in here. If you got to put it in here, then you got to put it in here. Okay, so we have triangle CAB, and what's the final question ask us? Find all the unknown sides. So they want us to solve the triangle. So we're going to quickly just put in the information we have. Angle C is 30 degrees. Let's do it in black. Angle C is 30 degrees. Angle A is 80 degrees. We're looking for angle B. That's one of the things. How can we find angle B from the information we have? Do you know what a triangle's angles are going to add up to?
180.
Yeah, that's right. So since we already have two of the angles, okay, we can add up to 180. So we'll take 180, subtract 80, so we're down to 100, and then we'll subtract 30 from that. So the other angle in this is going to be 70 degrees. So already we've discovered that angle B is 70 degrees. So that's part of the information we needed to find. Okay. They also said side C is 27. Now, I've named the angles. How do I name the sides from this information? Do you know?
Not too sure.
No. Okay. A side, okay, is usually represented by a lowercase letter, and it's opposite of that angle. So if this is angle C, this is side C. If this is angle A, this is side A, and if this is angle B, this is side B. So we're going to quickly just put the letters down for all of them right now. So side C is opposite angle C.
Oh, I get it.
Side A is opposite angle A. And side B is opposite side angle B. Okay, so that's how you name the letters. Then I know which side to call 27. Otherwise, I'd be a little lost. So this is 27 centimeters. Oops, let's put that in black again. What am I going to do? Let's move this over just a little. Okay, so this is going to be our side C, which is 27 centimeters. Now, these formulas here are primary trig ratios, okay? That's what they're called. So usually they're called SOHCAHTOA, right? They can only be used with 90-degree triangles or right angle triangles. Is this a right angle triangle that we have here? No. So we actually can't use any of these. We're going to have to use either sine law or cosine law. This is what you're doing right now in class, isn't it? Okay, so, yeah, just learn this stuff. Now, sine law and cosine law. Sine law, I'm going to tell you right now, is the easier of the two to use. And you use it when you can set up an entire ratio, okay? So what I'm going to do is I'm actually going to put that formula out here. Let's just grab it quickly. So sine law, put it in here. Okay, so we have our sine law. Just move it. We've called our triangle ABC, which works great. So we can now plug those values in, okay? And we're going to see if we can use sine law by plugging them in. So, first off, our A's. Our angle A was 80 degrees, so that gives me sine. The uppercase letter is the angle, so sine 80 divided by Do I have the side of A? Do I know that measurement? No. So I'm just going to represent it with A. Okay? Is equal to, and then B. B we did in green. Angle B is 70, so I have sine 70. Do I know what side B is?
No.
Nope. So again, I'm going to represent that with just the letter. And finally, C. Do I have angle C?
Yeah.
What is it?
27.
That's side C.
Oh, sorry.
The angle is
30.
30. Yep, that's right. And the side is 27. Now, in order for sine ratio to work, what you can do every time is plug these in. If you have a complete ratio, and what I mean by that is the opposite side and the opposite angle, okay? And if you notice here, I have the angle and the side. When you have a complete ratio, you can solve for all the other ones, as long as you have one piece of information on one of the other sides, okay?
If you don't, you can't.
If you don't have a complete ratio, so if you don't have an opposite side of an angle, so if you don't have the measurement of an angle and its opposite side, you can't use sine law. You don't have enough information, which probably means you'll have to go into cosine law, which is a little more difficult to calculate, okay? So this one's usually the easiest. So luckily we can use sine law in this question. Now, I have two equal signs and I have two other ratios I need to solve for. I'm just going to solve one at a time. I'm going to have to use this one because it has all the information. Let's go for the B, okay? And what that means is I'm not going to use A to start off, okay? I'm just going to leave it out of the equation, so put a little line through it here. And we're just going to work with those two ratios that we have. So we have sine 70 over B is equal to sine 30 over 27. Okay, so we have the sine law here. We've set it up. Now, what this is essentially this is two fractions, okay? These are both fractions, and they're equal to each other. So to get rid of fractions, do you remember doing this in maybe elementary school, cross multiply?
Yeah.
Yeah, so we can cross multiply. And multiply the bottoms by each other to the other side.
Wait, I have a question. Wait, so if we wanted that.
So when we go to cross multiply, that means the 27 is going to come to this side of the equation. There we go, now it's running smooth. Times, and it's going to be 27 times sine 70 is equal to sine 30 times B. Okay, so what we did is we moved the B, we moved the letters over. So now we're not really dealing with fractions. But the whole point of this is we're trying to isolate B. We want to find out what side B is. So I need to move this sine 30 to the other side. Okay. So once again, I'm going to have to divide. Okay. I have to divide both sides of the equation by sine 30.
Well, I thought you solve it first. Then.
You're right, we can. If you want to make this simpler, we can solve this, get a full number here, solve this and get a full number. And in fact, if you want to do it that way, let's do it that way. So, calculator here. 30 sine 0.5 works out nice. So let's move down a step here. We get B times sine 30 was 0.5. Okay, and sorry, let's not do the 27 yet. Let's do 70 sine times 27. 25.37. Okay, so we got 25.371 roughly. Okay, with the 3 decimal places. Now, it's important to say as accurate as possible in this. Okay, the more you start rounding early, the less accurate your answer is going to be. You might be off by a centimeter or a tenth of a centimeter. Okay,
because my teacher always wants us to round to 4.
To 4? Okay, so then let's go to 4. 1 ends, put that 7 in there. Okay. Alright, so we're on the 4 decimal places. Now again, like we said, the goal is to isolate for B. So when we move 0.5 to the other side of the equation, 25.3717 divided by 0.5. Okay. Alright, and what I did, actually, this is going to keep really accurate because right now on the calculator I've left my old number in there, and if you have that option to use an old answer, it's best. So I have that old answer in there, and I'm just going to divide that old answer by 0.5. So that's much more accurate than retyping this in.
Okay.
Right? And then we got 50 point, and then you said you wanted 4 decimal places?
Wait, so is that for the degree though? That's for
no, this is for the length of a side. 50.7435. 4. So we go back up to the top. Right? What we just solved was side B of the triangle. Okay, side B. So that means this side of this triangle is 50.7434 in length. Okay, so we'll write it in green here. So B was equal to 50.7434 centimeters. Okay, that was our B. We just figured it out now. Highlight this. That's part of one of our answers. Okay, that was our B. We also found out 70. That was one of our other answers. And now with this information, let's go back to our sine law. We'll go to the next page. Okay, so there's that triangle. We've put in our new measurement. Okay. Now, if we have two sides on a right angle triangle, we can find the other side by using Pythagorean's theorem. But again, this isn't a right angle triangle, so I can't use that. I have to go back to, again, my sine law or cosine law. So we've used sine law once, so that means we can definitely use it again to find the other part. So I'm just going to bring it over here. We got sine law here, and what we're going to do is we're going to plug in our numbers once again, just like we had done before. Okay, so let's say sine A, again, we had sine 80 divided by, we still don't know what A is equal to, and then we have B. Now, the angle is 70. The measurement was 50.7434, I think, right? Because you wanted it to 4 decimal places. And then C was sine 30 and 27. Okay? Obviously, this triangle is not written to scale because the side that's 50 looks like it's shorter than the side that's 27. It's not to scale. Okay? But we have our sine law here. And I actually have two sets of complete ratios. I can use either of these. I can use my B's, the angle and the side, or my C's to solve for A. Personally, I'm going to work with this one just because it's nice round numbers. This one's already got a decimal to it. It's not that we won't be able to do it. It's just maybe a little more difficult, more confusing to look at. So this time what we're going to do is I'm going to drop the middle ratio out, and I'm just going to work with the other two I have. So we have sine 80 divided by A is equal to sine 30 divided by 27. Okay? Same idea. Do you remember what the first step is here to get rid of the fractions? Something we would have done in elementary school. Yeah, that's right. We want to cross multiply, right? So we're going to have 27 times sine 80 is equal to sine 30 multiplied by A. Okay, so we have that down. And like you said before, we can equate everything before we start moving things over. Sine 30, do you remember what it was?
Sine 30. 0.5.
Yeah, that's right. It was 0.5. Good memory. All right. So we have 0.5 times A. And then on this side, we're going to have to calculate 80 sine times 27. So we get a large number here. We got 26.5898. Okay. So we have that now. Remember, the goal is, once again, solve for side A. So we need to divide by 0.5, the other side of the equation. So we'll get 26.5898 divided by 0.5. And we're going to get A is equal to. Again, I kept that number in there, so it worked out nice. It'll be very accurate with what we're going to get. 53. 53.1796 looks like. So, for all that work, we've got our three answers. Okay. 53.1796. So we'll go back up to the top. A is 53.1796. And just to make sense of this, really looking at these angles, okay? This is 30, 70, and 80. Okay. The side that's opposite of the largest angle should be the longest length, right? If you think about it, let's do a little demonstration here with some lines, okay? So we have this line here. We have this line here. We have a small angle to start, okay? But as I increase the angle, watch the distance of these two. The distance between them gets larger and larger and larger as the angle gets bigger, right? So if I have a small angle, the distance between these two here, relatively small. But as that angle gets bigger, obviously the side opposite of it is going to get longer. So let's reference this. 80 degrees is our largest angle. Is 53.1796 the longest side?
Yes.
Yeah. 70 is our next largest. Is 50 the second largest side?
Yes.
And 30 is the smallest. Is 27 the smallest side?
Yeah.
Yeah, so that makes sense. This would be a logical answer for what we're looking for.
Oh, I get it.
Okay. We got a word problem here, number 131, right? Okay. It says we got a radio tower. So let's draw our beautiful radio tower here. Okay. It's got some kind of satellite. There's our radio tower. And it says it's attached by two wires, right? At the top. So we have one wire here maybe, and one wire here, keeping it afloat. And we're going to say that this is the ground here. Okay, so here's the ground. Here's our radio tower. It says that the wires form what angle at the top?
It forms 80 degrees.
80. So from wire to wire is 80 degrees. Okay. What else does it say?
On the ground, the ends of the wire are 20 meters apart.
Okay. So we have from here to here is 20 meters. We know that. And what else?
And one wire is at an angle of 40.
Okay, so let's...
So it could be either or.
Yeah, it's going to be either or, because when we go figure it out. Now, to scale, you know, it might look funny, just like in the other one. Our triangles obviously wasn't to scale because 27 was the largest side, it looked like. We'll just call this one 40. What I want to do, after I've drawn this picture, I'm going to redraw the triangle without all my towers and stuff. I'll let that go. Okay, just so it's a little clearer of what we're dealing with. So we have triangle. We know the triangle is 20 meters across the base here. The angle at the opposite of it is 80 degrees. And we just said this angle here is 40. Doesn't matter. It'll be fine either way. Okay. Now I'm going to name the triangle. Sine law is named with A, B, and C. So I'm going to use, let's say, A. If this is A, what side is A?
Opposite side.
Opposite side, which is our 20, right? So this will be A. Call this B. If this is B, what side is B?
That side.
Yeah, that side. So we go across. That would be my side B. And finally, by deduction, we got C, right?
Yeah.
And side C. Is there any information I can find out very quickly without using any sine law or cosine law?
All angles equal to 180.
Yeah, that's right. Okay. So let's find out that other angle. We have 180 to start. One of the angles is 80. So we subtract it from it. What do we got?
100.
Yep.
And
Yep. So
60.
Great. So what angle is 60 degrees?
C.
C. Good. We got all the angles already. It's a good question, actually. What exactly are they asking us? We've already gone about trying to solve things, but we don't know what they're asking us yet. So the question actually asks us, how long will the wires be? So let's go back to our diagram. That's why it's always good to have two of these. This is one of the wires here. Okay, that's one wire. And the other wire is this one here in our diagram. So when we go to redraw this in the triangle, it looks like that's one of the wires, right? When I redrew it. And that's the other. So what sides are they looking for?
Oh, see, find angle CA.
Well, we have the angles. We're not looking for the angles. We're looking for what?
The sides.
Yeah, the side. So this is what we named B. So they're looking for side B and for side...
That's kind of like what we just did.
Yeah, it's exactly like we just did. You want to try it out? Oops. Oops. Number 125 says two sides of a triangle measure 18 centimeters and 25 centimeters. So let's say 18, 25 centimeters. And then it says the angle between them is 50 degrees. So between these two is 50 degrees. How long is the third side? So we're just looking for this side here. Okay. Now, quickly looking at this, will I be able to use sine ratio? Will I have any opposite sides and angles to set up?
Yeah.
I do? Do I have this angle here?
Wait.
No.
Wait, what is it missing out here?
It just says two sides of a triangle. So, I don't have this side, but I do have the opposite angle, but that's not a complete ratio. I don't have this angle, and I can't solve for it because I'm missing two of them. And I have that side, and again, I'm missing this angle. I don't have a complete ratio. I don't have an opposite side and an angle, which means I can't use sine law. We can't assume it's right angle, so we can't use SOHCAHTOA. Okay, we can't use any of those. We have to look into cosine law. Okay, so they might show you 3 different formulas for cosine law. Excuse me. We're just going to focus on one, this formula here. And instead of trying to memorize all 3 different ones, we're going to name our triangle specifically. With this one here, where we have the C's on the outsides, that means we're looking for either side C or angle C. So when we name this triangle, we're going to name it, whatever side or angle we're looking for, we're going to call that C.
So name the bottom one C?
Yeah, so this will be side C, which will make this angle what?
A. So
what's opposite of it?
Sorry, C?
Yeah, it's always going to be the same letter, right? So that's going to make that angle C. Then, kind of like Pythagorean's theorem, it doesn't actually matter what I name the other two then. Okay, so let's call this B. That's angle B, which will make this side B. And we'll make this angle A, which makes this side A. Wow, looks like a nut. So that's an A. Okay? So now that we have that, we're going to plug it into the formula. Okay? So we're looking for side C. So we plug it in here as, like we said, C. So we have C squared is equal to side A. Do we have a measurement for side A?
Yeah.
What is it? 25. That's right. So we have 25 squared plus, do we have a measurement for side B? 18, that's right. So we have 18. Then we square it. Remember, the squared is because of the formula. Minus 2 times side A is 25. Okay. Times side B is 18. And then cos angle C. Do you know what angle C was?
Angle C was.
Says in the question.
Oh, 50.
Yeah, it's 50. Good. All right, I'm just going to underline these so you see that they're in the equation here. Okay. So we color-coded things, so we've tried to make sense of what we're doing here. Okay. Okay, so we're trying to find the side C, so we have to use our bed mass to go through this. Okay. So with our calculator, I got C squared is equal to 25 squared, 625. Okay. So it's equal to 625 plus 18 squared, 324. So plus 324. Now you can think this as a subtraction sign or a negative 2. I'm going to put subtract and then 2 times 25 times 18. Okay, that's what that says there. 2 times 25 times 18 equals 900. So we have minus 900. And I'm not going to solve cos 50 yet. I'm just going to leave it as cos 50 to start. Okay. I'm going to add up those other two, 625 plus 324. That's 494. 949, sorry. 949 minus 900 cos 50. Okay. Here is the confusing part. Many students look at 949, subtract 900, and subtract the 2. We can't do that because this technically says negative 900 or subtract 900 times cos 50. So I have to equate this first according to BEDMAS. So I do my 50 cos and get a large decimal. And instead of just writing that number in, I'm going to multiply it by our 900. Okay, multiplied by 900. Okay. Now I have a number that I can subtract. So I have C squared is equal to 949 subtract 578 point, and your teacher wanted 4 decimal places, right? 5088. Okay.
I don't think you did.
Still a close. It's a fine. The more accurate we are, the better. Okay, so it doesn't really matter if we write them all in. That's even better. We're even more accurate. 949 subtract 578.5088 gives us 370. 370.4912. Okay. Now I still have c squared on this side. I've left it over there by itself. Yeah, how do I bring the squared over?
Like the square root does this.
Yeah, I need to square root both sides of the equation. Okay. So we'll be left with side c, which will be equal to, and we find the square root of this number. So I can quickly, on my calculator, I can just hit this number. You might have to put in a button that says answer or something. I put it in, we get 19. You said we can round it.
Sure.
We'll say it's 19.24. If they want to round it, what we could say right after that is C is approximately 19. I think it was in centimeters, right?
Yeah.
Centimeters. So then the opposite side in this question would have been 19 centimeters.